This is my final video walkthrough. First, I'm going to show that my code compiles without warnings or errors. As you can see, my code is successfully compiled. Now I'm going to show an example of signals and process management of my code. So I will put sleep 100 in background. And now you can see that it is the first background process and its process ID. I can prove that by the ps command. Now I'm going to put sleep 10 in the background as well. You can see it's the second and its PID. And now if I type ps, I can see both sleep commands and their PIDs. Now that 10 seconds has passed, the second command, which is sleep 10, has terminated. So the termination message is printed. And now if I type ps, I can only see the first sleep command. But I don't want to wait 100 seconds. So I'm going to manually terminate it by calling kill and then put its PID. As you can see, the sleep process has been killed. And now if I type ps, I can see that there's no process remain. Now I'm going to work through some codes about signals and process management. So I have a struct for each process, which contains their process ID and the command name and the command message. Then I created an array of processes and declared in mesh.c. Here. This is the handler that is called when a child terminates and the signal is sent to the main process. So when a child terminates, it will search its PID in the processes list. When the process is found, the down message is displayed on the console, and the PID at this index will be set to -1. Here I declared a SIGAction struct so that when the child process terminates, the child handler will be called. So the terminated process will be removed from the process list and the corresponding down message will be printed. This code creates the down message when a command is put in the background. So the program will find the first free spot in the process list, and then it will store the command name, then down message. The pros of my approach is that as soon as a child process terminates, the down message is printed instantly. In addition, this is more CPU friendly because I don't have to constantly checking if a child has terminated in every loop. But my approach also has some drawbacks. For example, when a signal is received when the program is printing the prompt, the resulting message on the console will be undefined. Another approach I have thought when I was implementing this feature is to call waitPID with a wait no hang option, which checks for terminated processes in every loop. The benefit of this approach is that the implementation is much easier. But there is a serious drawback. It is not very CPU friendly, because if I check for the terminated child processes too often, then I will use too many CPU resource. In addition, the DOM message will only be printed when I type another command, which is why I didn't choose this approach. Now I'm going to walk through the code that handles receipt of message from clients. So in the server code, I use select on all the client sockets, which will return the client socket as soon as there's something to read from that socket. Then the program will find the corresponding client struct using while loop, and then it calls read from client function on that struct, and this function will return 0 if the full message has been received, and 2 if it partially read the message. Then the program calls getMessage to try to read the whole message from the client struct. And here is the implementation of getMessage. So the function will first find the network new line from the buffer that stores what's read from the client socket. And then it will allocate a chunk of memory for this message depending on its length. So even if the client sent a very long message, a larger chunk of memory will be allocated. So as long as the heap is not full, there will be no error. And then the rest of code is just removing the message from the buffer and set the correct inBuff. After the whole message is read by the server, it will be written to every client that is connected to this server. So the advantage of my approach of dealing with very long messages is that I don't have to worry about the length of the message as long as my heap is not full. But there's also a drawback. Firstly, the implementation is a little bit complicated, so it is easier to make mistakes. Secondly, if there are multiple messages from clients in the buffer and there's an error with the first message, the client will be kicked from the server and the client has no idea which message caused the error. So the client might make the same mistake next time connecting to this server.